Now I want to look at array class methods. So we're going to look at just a few of them. We're going to look at reverse. We're going to look at sort. We're going to look at binary search. And we're going to look at clear. So these are the array methods that we're going to be looking at. So we can start with reverse. Right? Let's say we have array A and array B. And this is array A. Array A has got 6 elements and array B has got 12 elements. Right? So we want to write a program that makes use of the reverse function from the array class so that we reverse this function. Right now you can see it's starting at 20. When we reverse it, it will be starting at 50. So we want to print the array before reversing and then print it after reversing. So we use for each. A. Right? We can just print something that shows that this array is actually being printed before it's reversed, right? Console.write line, write line, array A before reversing, right? This is array A before reversing. And now let's use the reverse function from the array class. So you have to write the array class first, then reverse. Right? Reverse. Then we write the name of the array that we want to reverse. Right? Then after doing this, now we want to print the structure of the array after reversing. So we just copy this code after reversing. Right? Let's see how it come out like. Right? So this is the original array. It starts with 20 and 50 is the last element, this one. And after reversing, 50 is now starting, followed by 10, and 20 is the last. So that's how the reverse function operates. So now we want to look at sort. So forgive me, I'm just going to change the code inside. I'm just going to update this code. So for sort, you have to write this function, sort, right? And then after sorting, we can just change here before sorting, right? Before sorting. This is after sorting, right? Let's run it. You see, sorting, it automatically sorts everything in ascending order, right? So 10 is the smallest value, so it becomes the first item in the first index, and 60 is the biggest number, so it becomes the last number. So everything has been sorted in ascending order. So if you want to sort in descending order, you will then need to reverse this new array. In that way, we not sorter in descending order, right? So we also want to look at another technique that you can use for sorting. You can actually choose to sort a certain section of an array. For example, in this code, we were sorting everything. But if you want to sort a certain section, you have to extend this. Let's say maybe we want to start sorting at the second index and third index, which means 0, 1, 2, 3. We want to sort 30 and 60, right? That's what we want to sort. Right, as you can see, 0, 1, 2, 0, 1, 2, 0, 1, 2, right? And 3, 0, 1, 2, 3, 0, 1, 2, 3, which means we have done the right. So the number 2, it means we are starting at index number 2. So this is 0, 1, 2. So we are starting here, right? Then the number 3, it means we are counting 3 elements from the first index. So it means we are counting 1, 2, 3. So this section is the section that we want to sort. So if we sort this in ascending order, in the place of 10 of 30, 10 will replace 30, and 30 will replace 60. Then 10 will be replaced by 60, such that the array will look like this: 10, 30, 60. This is the section that has been changed, right? Now we want to look at binary search. We want to look at binary search, right? Let me remove this so I do not have you are not confused by all of these things. So in binary search, we use the binary search function from the array class, and this function, it retains the position of the value that we'll be looking for, right? It retains the position of the value that we will be looking for. Let's say we are looking for, first thing, it returns an integer, so we have to declare an integer. Let's say p for position equals to array dot binary search. Then we have to write the name of the array and the value that we want to search. Let's say we want to search 30. This would mean that the p that will be returned by this function will be the position of 30, right? So apparently, maybe before I talk about that, I want you to see it for yourselves. I want you to see this. Let's just print. We want to print the value of p. Right line. The position of 30 is, right? The position of 30 is, we want to use this method here. The position of 30 is, then p. Right? If we run this, this is what we're going to get. The position of 30 is 2, which means 0, 1, 2. So 2 is the index, and that's the position of 30, right? You might want to make the code a little bit more interactive. If you want to make it interactive, then you have to ask the user to enter something, right? Right line. Please enter the number you are searching for. Please enter the number you are searching for. right? And then we want to capture the number. We can call it num is equals to convert dot to int 32 then console dot read line. Console dot read line. Right. Then we want to, after that, we need a loop. If, sorry, here we have to write the number such that the number will be searched using the binary search, right? Then we need a loop here. If P, right? If this P is less than 0, right? If this P is less than 0, then if the P is less than 0, then we know the number is not there, right? If P is less than 0, console dot write line. Then we have to type something here. The number you are searching for is not available. Right? Then else let's just take this. Right? So this is our array, and we want to look for a number that doesn't exist in here. Let's look for 100. The number you're searching is not available, right? Let's search for 10.